Students, exponential decay is when a substance decays at an exponential rate. It started off with a lot and then it just decreases. One of the very best ways to see this in our world is in radioactive material. Yes, radioactive material has what's called a half-life, meaning it takes a certain amount of time for half of the substance to go away. Now, radioactive material can be used for good. In fact, it's used as a wonderful treatment to help people reduce the size of their cancer cells in their body. This particular problem, oncologists, that is the word for doctors who specialize in cancer treatment, oncology. So cancer treatment doctors or oncologists utilize cobalt-60, which is a radioactive material, in radiation therapy. If the half-life of cobalt-60 is 5.26 years, how much of a 20-gram sample would remain in your body after 15.78 years? So that's the double-edged sword of radiation therapy, is it helps you decrease the size of your cancer cells, the number of your cancer cells, but it also stays in your body for a very long time because the half-lives of radioactive material are usually pretty long. Let's look at how to solve this problem. We go back over here to our exponential growth equation, and what we're going to notice is that exponential decay and exponential growth are extremely similar. We still put our initial amount. So in this case, we had 20 grams of cobalt-60. 1 plus the growth rate. Well, in this case, we're not growing, we're not getting bigger, we're getting smaller. And half-life, well, what's a half? A half. So instead of adding 1/2 as a growth rate, we're going to subtract 1/2 as a decay rate. A decay rate. Like I said, we're going to subtract that rate. And then, of course, it's the same as always, times, raised to the t power, and t is the number of time periods that this substance has decayed. So we have y equals 20 times, well, 1 minus a half is a half. Now t, the number of time periods. 5.26 years is how long it takes for cobalt to decrease by half. So how much would remain after 15.78 years? Well, let's figure out how many time periods are in 15.78 years. Well, 5 goes into 15 about 3 times. So my guess is that 5.26 could go into 15.78 3 times. Let's check it out and see if that's correct. 5.26 times 15.78, divided by 15.78, and we're going to move the decimal place over 2 times for both of them. Well, let's multiply by 3 and see if we get it. 6 times 3 is 18. 2 times 3 is 6, plus 1 is 7, and 3 times 5 is 15. So indeed, there are 3 time periods. Cobalt-60 over this time period would have gone through 3 half-lives. And that is why our t time period will be to the 3rd power. So what's 1/2 to the 3rd power? Well, 1/2 to the 3rd power, we must distribute the exponents. So So to the third power goes to this first power, and to the third power multiplies to this first power. So we have 1 cubed over 2 cubed, which is 1/8. 2 times 2 times 2 is 8. So we end up having y equals 20 times 1/8. 20 is like 20 over 1. We multiply the numerators and the denominators, and we get 20/8, which is 10/4. We divide both sides by 2, and we can divide both the numerator and the denominator by 2 again to get 5/2. So y equals 5/2 grams, or 2.5 grams. So over 3 time periods, which is the same as 15.78 years, a 20-gram substance of cobalt-60 will have gone through 3 half-lives, which means it would be 2.5 grams remaining after 15 years. That stuff doesn't like to go away quickly, does it? With exponential decay, remember, you put your initial amount times 1 minus your decay rate, and then you increase that exponentially to the number of time periods. Thank you very much.